if you were with me Friday for graphing day, this graph is shifted to the left where it has a vertical asymptote at x equals -3. But remember, like any other graphing day, left 3 does not mean x minus 3. It means x plus 3. The restriction is x cannot be -3, which is why this graph never touches -3. Can't divide by 0. That's a huge rule in this unit. So this one might have seemed a little tricky. You might have thought 9, but 9 squared minus 9 would not be 0. But you might notice this one factors to x plus 3 and x minus 3. It's a difference of squares, which would mean it's got to be this one and this one. You can always put it in Desmos and see that it has asymptotes at those spots. Vertical asymptotes at that. How many vertical asymptotes are we going to have? Looks like we got 2 restrictions, and neither of them will cancel to make a whole, so there are going to be 2 vertical asymptotes. Matching these up was probably a little strong, but what I've noticed that I've been able to do a little bit easier not using Desmos. I try to find the ones that are real simple, like this one will have a vertical asymptote at +5, because you can't have 0. 5 minus 5 would be 0, so a vertical asymptote at 5. And this one's going to have a vertical asymptote at +1, because 1 minus 1 would be 0. Now these that look a little tougher, they have 2 things going on. If it cancels out, neither one of these cancel out, by the way. That's the x minus 1 with the x plus 1. That's going to be 2 vertical asymptotes. -1 and +5, yep. Over here, though, this one looks the same. The x minus 5s will cancel out, which means that's going to be a whole at 5. And then finally over here, the one that's covered up, x minus 1 would cancel. I'm sorry, the x plus 1s would cancel, meaning there's a whole at -1. Cancels out, it makes a whole. It doesn't cancel, then the restriction is a vertical asymptote. Probably went a little bit over the top with these, but there was one of these on the test last semester, because I think it was on the most missed version. But anyways, we got 1 restriction, and that restriction is we have the restriction is x cannot be -7, because -7 and +7 would be 0. That is a vertical asymptote. That vertical asymptote is at x equals -7. And then there's a horizontal asymptote when the degree on the bottom is larger. I did one for you earlier when they're the same degree, but if the bottom one is larger, it's automatically at y equals 0, but the +2 shifts us up to best seeing that on Desmos. That would have been a really good candidate to type in and check the horizontal asymptote. Over here, we got 2 restrictions. There's a vertical asymptote at this one that does not cancel out. That would be at 4. The restriction would be x cannot be 4. There's a whole at the one that canceled out, which would be -3, because x can't be -3, because that would be a 0 on the bottom. I'm still saying on the bottom. You say denominator. So this question is up here for a very important reason. So for this last equation, again, as I was showing, most of y'all would probably put it in Desmos, use 2 separate lines, see that they cross at 2.8, and you easily got your answer. 2.8 is 14/5. But if you need to work it out, which is great, remember you don't need no common denominator because you're not adding. All you have to do is to cross multiply for these. So I got to do 2x minus 3 times the 4x plus 5. But I also got to do, and again, I should make bigger boxes. I got to do x minus 1 times 8x plus 1. Now, whatever I get this time, it's an equation. There's an equation in the middle. So I'm going to have these parts and these parts. But a lot of them are going to just cancel each other out. So there's a 8x squared, a -12x, a 10x, and a -15. Hopefully I did that right this time. Finalizing at 8x squared minus 2x minus 15. On the other side, I get another 8x squared. I can tell they're going to cancel each other out. Minus 8x, a x, and a minus 1. So again, hopefully I didn't go too fast and mess any of that up. If I subtract my 8x squared, whichever one, they just cancel out. That's great. If I want to put my x's together, it's easier to move the smaller one. The smaller one is the negative 7x. That will add 7x to make 5x. There's still a minus 15. There still equals negative 1. It works out real clean from here. Add 15 and you get 14. And remember, you're going to divide off that 5, which is the same answer we had over here, just putting it in decimals. But shout out to those of you that like to work stuff out by hand.